In this section, we will learn how to wire the buttons to the Raspberry Pi Pico Macropad and program them using CircuitPython. We will use 6 buttons for this project, but you can add more if you want. First, we need to solder some wires to the buttons. Each button has 2 pins, one on the left and one on the right. We will use 30-gauge wires for this. Cut 6 wires of different colors and strip the ends. Solder one wire to the left pin of each button. Then, solder another wire to the right pin of the first button. This wire will connect all the right pins of the buttons together. Next, we need to connect the wires to the Raspberry Pi Pico. The left wires of the buttons will go to different GPIO pins on the Pico, while the right wire will go to a ground pin. You can use any GPIO pins you want, but we will use GP7 to GP12 for this example. Here is how we will connect them. Orange wire. Button 1 left pin to GP7 blue wire. Button 2 left pin to GP8 green wire. Button 3 left pin to GP9 yellow wire. Button 4 left pin to GP10 purple wire. Button 5 left pin to GP11 pink wire. Button 6 left pin to GP12 black wire. Button 1 right pin to GND. You can use a breadboard or a soldering iron to make these connections. Make sure the wires are not touching each other or any other pins on the Pico. Now that we have wired the buttons, we need to program them using CircuitPython. CircuitPython is a version of Python that runs on microcontrollers like the Pico. It has a built-in USB HID library that allows us to make the Pico act like a keyboard or a mouse. To use CircuitPython on the Pico, we need to flash the firmware and copy some files to it. Here are the steps. Download the CircuitPython UF2 file from https://circuitpython.org/board/raspberry_pi_pico push and hold the butzel button and plug your Pico into your computer using a USB cable. Release the butzel button after your Pico is connected. This will mount the Pico as a mass storage device called RPIRP. Copy the UF2 file to the RPIRP2 volume. Your Pico should automatically reboot and will be running CircuitPython. Download the project zip file from https://github.com/novaspirit/pico_streamdeck. Transfer the contents of the zip file to another volume called CircuitP that appears on your computer. Overwrite any existing files. Reboot the Pico, and it should load the code for the Macropad mouse. The code for the Macropad mouse is written in Python and stored in a file called code.py on the CircuitP volume. You can open it with any text editor and modify it as you wish. The code uses 6 variables to store the GPIO pins for each button: BTN1, BTN2, BTN3, BTN4, BTN5, and BTN. It also uses 6 variables to store the mouse actions for each button. Action 1, Action 2, Action 3, Action 4, Action 5, and Action. The code uses a loop to check if any button is pressed and then performs the corresponding mouse action. For example, if button 1 is pressed, it moves the mouse cursor up by 10 pixels. If button 2 is pressed, it moves the mouse cursor down by 10 pixels. If button 3 is pressed, it moves the mouse cursor left by 10 pixels. If button 4 is pressed, it moves the mouse cursor right by 10 pixels. If button 5 is pressed, it clicks the left mouse button. If button 6 is pressed, it clicks the right mouse button. You can change these actions by changing the values of the action variables. For example, if you want button 1 to scroll up instead of moving up, you can change action 1 from 0-10 to 0-1 scroll. You can also combine actions by using lists or tuples. For example, if you want button 5 to click both left and right mouse buttons at once, you can change action 5 from click to click right_click. You can find more information about how to use CircuitPython and its USB HID library at https://learn.adafruit.com/welcome-to-circuitpython/circuitpython-libraries. That's it. You have successfully wired and programmed your Macropad mouse using Raspberry Pi Pico and CircuitPython. You can now plug it into any computer and use it as a mouse controlled by buttons. In this section, I will show you how to design and print a 3D case for the mouse that fits the buttons and the Macropad. A 3D case will protect your device and make it look more professional. The first step is to download the 3D model of a Raspberry Pi Pico and a Macropad. You can find them online or use the ones I have provided in the description. Make sure to check the dimensions of the models and compare them with the actual devices. The second step is to open a 3D modeling software of your choice. I will use Fusion 360, but you can use any software that can export STL files. You will need to create a new project and import the Pico and Macropad models. The third step is to design the case around the models. You will need to measure the distance between the buttons and the Macropad, and create holes for them on the top part of the case. You will also need to create cutouts for the USB port, the display, and the rotary encoders on the sides of the case. You can add some extra features like feet, vents, or logos to make your case more unique. The fourth step is to export your case as STL files. You will need to export two files. One for the top part, and one for the bottom part of the case. Make sure to name them clearly and save them in a folder. The fifth step is to slice your STL files using a 3D printing software. I will use Cura, but you can use any software that supports your printer. You will need to load your STL files and adjust the settings according to your printer and filament. Here are some recommended settings. PLA 15% infill 3-line wall thickness. No support needed. 0.2 layer height. Use 0.1 layer height for higher quality. Print separately with two different colors. The sixth step is to print your case using your 3D printer. Make sure to check the progress and quality of your prints, and remove them carefully from the bed when they are done. The seventh step is to assemble your case and test your mouse. You will need to insert your buttons and Macropad into the holes on the top part of the case, and connect them with wires to the Pico. You will also need to place your Pico inside the bottom part of the case, and secure it with screws or glue. Then, you can snap or screw together the top and bottom parts of the case, and plug in your USB cable. Congratulations! You have just designed and printed a 3D case for your mouse that fits the buttons and the Macropad. You can now enjoy using your mouse for various tasks and projects. In this section, we will learn how to test and troubleshoot the mouse functionality and customize the button actions. To test the mouse, plug the Raspberry Pi Pico Macropad into your computer using a USB cable. The Pico will be recognized as a USB keyboard and mouse by your operating system. You can use the 6 buttons on the Macropad to control the mouse cursor and clicks. The 4 buttons on the right-hand side are for moving the cursor up, down, left, and right. The 2 buttons on the left are for left and right clicks. Pressing both at the same time will initiate a middle click. To scroll with the mouse, hold down the left and right buttons while pressing one of the directional keys to choose the direction you would like to scroll. If you encounter any problems with the mouse functionality, such as lagging, jittering, or unresponsive buttons, you can try some of these troubleshooting steps. Make sure your Raspberry Pi Pico has the latest CircuitPython firmware and libraries installed. You can download them from https://circuitpython.org/board/raspberry_pi_pico and https://circuitpython.org/libraries. Check your wiring and soldering connections between the Pico and the buttons. Make sure there are no loose or shorted wires. Check your code for any errors or typos. You can use a code editor such as Mu or Thani to edit and debug your code on the Pico. Adjust the delay and sensitivity values in your code to suit your preferences. The delay value determines how long the Pico waits before sending a mouse command to the computer. The sensitivity value determines how fast the cursor moves when you press a button. To customize the button actions, you can edit the code in the macropad.py file on your Pico. This file contains a class called Macropad that defines the button layout and actions. You can change the number of rows and columns of buttons, Assign different key codes or macros to each button, and add colors and icons to the buttons if you have an OLED display attached to your Macropad. You can also use the predefined empty configuration and empty macro classes as spacers. These will generate turned-off buttons that will do nothing. For example, if you want to change the button in row 1 column 1 to send a Ctrl+Alt+Delete command instead of moving the cursor up, you can replace this line. 0x01, 0x01. Button configuration, up, mouse macro, 0x00, sensitivity, with this line. 0x01, 0x01. Button configuration, CD, keyboard macro, keycode.control, keycode.alt, keycode.delete. You can find more information about key codes and macros in the CircuitPython documentation. https://circuitpython.rethodocs.io/projects/hid/and/latest. That's it for this section. You have learned how to test and troubleshoot the mouse functionality and customize the button actions of your Raspberry Pi Pico Macropad mouse. Have fun experimenting with different configurations and macros for your Macropad.